For how to draw a direction field, the easiest way to show is to just do one. So this isn't an ordinary differential equation because we could easily integrate. There's no y term, there's no y double prime term. We can just integrate the y prime, but it's a nice example. So we're going to go ahead and do that. I set up this grid here from x and y. Their bounds are negative to positive 6, and these ones in the middle here, that's pointing to 0 in the middle. And the way you calculate direction fields is the first thing is you have to calculate y prime at a bunch of different points. So that's what we're going to do. So when x is negative 5, we're going to plug in here. So I get negative 5 squared minus negative 5 minus 2. So negative 5 squared minus negative 5 minus 2. And I can't do these reliably in my head, so I have some notes. That ends up being 28. And then the same thing going down. So negative 4 squared minus negative 4 minus 2. That ends up being 18. And I should be putting these here while I'm doing it. So the y prime is 28 when x is negative 5. Y prime is 18 when x is negative 4. Negative 3 squared minus negative 3 minus 2 ends up being 10. So 10, negative 2 squared minus negative 2 minus 2 ends up being 4. That's 4. Negative 1 squared minus negative 1 minus 2. That ends up being, 0. And I've got 0 squared minus 0 minus 2. Well, that one I can do in my head. That's negative 2. So negative 2. And I've got 1 squared, and I'm just going to do it all in a rush here. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, minus, 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 1, 2, 3, 4, 5, minus, 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 minus 2. And those are going to equal, from my notes here, starting at 1, I have negative 2 again, 0, 4, 10, 18. Okay. So let me just put those in. So negative 2, 0, 4, oh, sorry, 0, sorry, I missed it. 1 was negative 2, 2 was 0, and 2 negative 2's in a row. Let's see. Then 0, 4, 10, 18. All right, so now we're going to go ahead and plot those as best we can. It gets really difficult to plot lines with a reliable slope that are bigger than 4. They kind of all just look like vertical lines. But we're going to try. So let's start out. When x is 0, the slope is negative 2. So that would be around this point, and I guess that kind of looks like negative 2. When x is 1, it's negative 2 again, so I'll try and copy that line. When x is 2, that's a 0. That one I can do. When it's 3, it's positive 4, so vertical line almost-ish. 10, so all I can do is make them really steep vertical lines, and that's 18. Going the other way, when x is negative 1, we actually have 0 again. And then positive 4, 10, so I'll try. 4, 10, super vertical but going up, super vertical but going up. So that's the slope field so far. And then one thing we can do is, I have a bunch of other grid lines here, and it turns out this y prime, it doesn't matter what the value of y is. No matter what, if we're at y equals 1 or y equals 2, 3, 4, 5, negative 1, negative 2, negative 5, it only matters what x is. So these lines end up getting duplicated. So I'm just going to draw them in, trying to keep it somewhat well made. All right. All right, it's just trying my best here. I forgot the lower half. Get that in a moment. Not the best slope field, made by human hands. All right. Oops, went too far. Okay, vertical-ish line with positive slope. You do have to get the value of the slope right. it's, it's positive or negative, that does matter. Then horizontal for slope 0, down -2, -2, 0, and then upward slope. That's quite steep. Okay, well that's the slope field. And then the next thing you can do is, one of the nice things about the slope field is you can try and kind of follow the slope field to draw the curves. So I'm going to use, let's try. So let's say it's slope 0, and it's going to go, it's going up and then it's going down. So it's going to look something like that. And then it keeps going down, but eventually it's going to have to get to 0 slope again. So something like that. And I'll connect them, and then it just keeps getting steeper and steeper. This just keeps getting steeper and steeper. And so that kind of makes sense if we actually integrate this. If we integrate y, we'll get y equals, let's see, that's going to be 1/3 x cubed from integrating x squared minus x, that becomes 1/2 x squared, and then the -2 becomes -2x, and there's going to be a plus constant. So the other thing is, right, I could have started at a different place, and I would have gotten a similar shape. I should have gotten kind of the exact same shape, actually, just, I gotta be careful here. Let's see. Okay, I did that reasonably well. Just shifted upwards. So that's the way you make a slope field, and the goal is to try and draw these. There's actually a link in the problem on my website for this really nice tool. This person, Ariel Barton, made, I think, the University of Arkansas, that will actually make the slope field for you, and actually if you click on it, it'll draw these for you as well. And if you actually did a good job, this isn't from our website, but if you actually did a good job, it'd end up looking something like that. This one actually has more points in between, right? That's 0, that's 1/2, that's 1. Right there is 1.52, 2.5. So it has twice as many slope lines, or I guess 4, twice as many in both directions. And that's the idea. And to be honest, it's actually quite difficult to do this with much accuracy, especially when the slopes get very large, because it gets harder and harder to distinguish between, a line with slope 28 and a line with slope 18. But that's the idea, and we'll do some more examples, and sometimes there's a shortcut you can take, like we did here, where we didn't have to worry about the y value, that we can, not compute it for the entire grid.